Welcome to the Innovators, the podcast where we talk to the people building the future. In each episode, we sit down with technologists, founders, researchers, and engineers who are doing real, impactful work. They're applying technologies in ways that change how we live, work, and think. Whether it's breakthroughs in AI, climate tech, health systems, or digital infrastructure, this show is about the people turning ambitious ideas into working systems. No hype, just thoughtful conversations with the folks making it happen. Welcome back to The Innovators, a podcast about amazing people doing amazing things. Today, we have something really, really unique. This is Pablo Zegers from Caspix. And Pablo, welcome. You're the Chief AI Officer over there, but what you're doing is purely analog, and it suggests that AI doesn't need a data center, which is simultaneously amazing and kind of scary. So welcome, Pablo, and tell us what you're working on.
Yeah. Thank you for the intro. What we have discovered the way of running artificial intelligences in hardware substrates that have errors. So we can do very efficiently all type of calculations, the ones you need for artificial intelligences, and still guarantee good results, even though your hardware has errors. And that allows us to run, for now, simple artificial intelligences in analog hardware. We don't require silicon, we don't require transistors, we don't require digital logic. So that's very interesting. And what we're trying to do right now in Caspix is to enable intelligence on sensors, on the edge, as it's called.
So what level of sensor are we talking? Are we talking like a heat sensor? Are we talking atmospheric? What does it look like?
It depends on the commercial application. Okay. We know from the technical point of view that we can do it, but now we're talking with several design partners to see what's the most appealing application where we give the most value. For example, sensors that can monitor themselves and do all the predictive maintenance and warn you 1 month before they are going to fail, that they are going to fail. Mm-hmm. Now they are limited to send a signal to a central computer, for example, in a car, and the central computer has to record all the data and tell somebody that the thing is going to fail. Everything changes if you somehow manage to put the intelligence close to the sensor or in the sensor.
Uh-huh.
That way you can decentralize everything in terms of sensors, and you can become closer to mission critical applications. For example, if you have a mining truck within a mine, now they are operating in a way that they need to convey all the information to a central processing unit, which is normally very far. But within mines, there are lots of problems, connection problems. So sending the information is not trivial. And if you have, for example, a truck failing within a gallery and blocks the gallery, you can stop the mine. And that's absolutely no go. So There are lots of applications where you need more intelligence in sensors. And that's where we're starting. Because once we have this working in sensors, we basically will commercially prove that we can do intelligence without requiring digital logic.
I'm still trying to wrap my head around it. Are we talking about literally just like a sensor on a chip? So what's the difference between this and running like an Arduino with a sensor attached to it, where the Arduino runs some of the AI to a degree? I mean, what you're suggesting here is not like the sensor knows. The sensor isn't super artificially intelligent. It has understanding of the range that it needs to be in, etc. What's the difference between that and like just a thermostat that can shut down a system if it breaks or something like that?
Yeah, I think the Arduino question is a very good one.
Mm-hmm.
And I would say our contribution is twofold. The first one is power. Our system, because it's analog, it requires much less power. So the range of applications grows a lot. You can do lots of very interesting stuff. And the second one is that once you can have an analog electrical circuit doing the matrix vector multiplications that are required for running artificial intelligences, there are several other ways you can build it. You can print them using inkjets. We cannot do that right now. We're in much simpler technology, but potentially you can do that. Or you could use lithography to print out very simple circuits that are able to do this, even though they'll have errors. So you open up a different way for building artificial intelligences that doesn't require current ways of doing digital chips. So it's twofold. One is the vertical, as we say, we are going into sensors and trying to give intelligence to sensors, basically because it's a market where we won't have any competition, say for the Arduino solution. And second one, if we manage to do something useful in this vertical, then we'll know that we are very close to giving everybody the capacity for building these analog circuits, which much simpler and cheaper technology.
What do these circuits signal? Do they like from what I'm imagining a coin battery connected to some wires connected to
this,
I don't know,
funny thing.
There's a buzzer and a light sensor, right? So if you put light up to the light sensor, the buzzer is going to go off. What you're suggesting is that there can be certain amounts of intelligence inside that light sensor that can make the buzzer go off at a certain point or at a certain range or at a certain something like that, which sounds wild to me. So I'm trying to wrap my head around what this is going to do, right?
Yeah, I agree. I would say that the buzzer example is too simple, but I like to think, for example, the tires in a car. Okay, so you have autonomous cars, and if you had a more intelligent sensor within the wheel, you could, for example, measure the characteristics of the highways. You could predict when the tire is going to fail, whether it's failing or not. Maybe you can measure the temperature of the tire that's going to relate to the outside temperature. You can start playing with the information within the tire and use that to convey some information instead of just sending a huge stream of data and processed raw data to a central thing.
Okay.
Yeah.
So I mean, one of the biggest issues with autonomous vehicles is going to be that stream of data, right? The Waymo, for example, probably blasts out endless amounts of satellite data as it's driving around just to make sure that it doesn't crash. But what you're suggesting is that every little piece of the car is going to be able to think, like the struts can sense and say, oh, something's wrong here. And then that's going to notify the main system, which might communicate back to the other systems.
Or for example, no, this is going to be a bad example. So
okay. Yeah. Well, I mean, you're blowing my mind here. So that's the difficult thing. I'm trying to figure out what the use cases are. How did you guys get into this?
That's a very good story. I'm 57 years old. And when I was in high school in 1984, I said artificial intelligence is going to be my goal. So I've been in artificial intelligence for more than 40 years. So yeah, I've been in this forever. And I've been trying to solve this problem for the last 30 years and finally managed to do it. And it's not magic. What we're using is the same electrical relation that voltage equals intensity of the current multiplied by the resistance. That's a typical thing. So we just print the resistances, and that's a process with errors. So the multiplication is done at the speed of light within the circuit. It's just so if we manage to print these resistances with very high densities, we can do pretty complex artificial intelligences.
Without powering a chip, without powering a transmitter, and without having to transmit that data constantly. So
exactly.
So it's almost like a lattice of circuitry that reacts and outputs values, I suppose, but intelligently. So you're actually doing math in a component.
Okay. Exactly.
Yeah, I think this is like I said, this is brushing up against the end of my home, my toy electronics kit that I used to have when I was a kid. So we've got to dumb it down for me. What are people saying about this? What are your customers saying?
We are just starting to work with the design partners. They're very excited because they see this twofold advantage. First, adding more intelligence to everything and to decentralize and stop requiring very high, very powerful centralized processing compute. On one side, on the other side, the possibility of controlling the fabrication of these devices, which is now basically dependent on very few companies in the world. So if you manage to do these analog circuits and have them printed at home at your factory, that changed a couple of things.
Yeah, well, it's much cheaper as well, right? There's essentially no cost associated with that.
Yeah, disposable.
Okay. You guys are raising funds right now, or have you raised?
Yeah. We got the final push with the Alchemist because we were accepted in their program, and they helped us to build the company. So we started it this year, and we're raising funding right now.
And where's the company based?
In Palo Alto.
Palo Alto. All right, very cool.
Yeah.
All right, I'm fascinated. This is personally one of the coolest things that I've seen. When you're done, what does the world look like?
I would say in the future, 50 years from now, all artificial intelligences are going to be run on technology like this, not digital circuits, because this is much more efficient.
Interesting.
And once you have this, because it consumes much less power, you'll be able to put artificial intelligences within a box. And many of the problems we're having right now with artificial intelligence is because it's centralized. If it's centralized, whoever controls the data center controls the AIs, and that poses a lot of trust problems. It can be hacked. In our case, if you use our printed analog circuits, once you print them, they're static. You can hack them. So if we were able to have this very powerful, we have a long way until we have a very powerful artificial intelligence running on this type of technology. But if we manage to do that, then you will be able to have your artificial intelligence sitting on your desk, and the data is not going to come out. So everything is secure, everything decentralized. So I see a world where everybody has one of these artificial intelligence cubes, if you tolerate that definition, sitting on your desk, talking to you, and that being your personal assistant, not something going back and forth over
and it doesn't
connection.
And it wouldn't need the traditional computer setup of a CPU, GPU, all that other good stuff. It's just basically built into the circuit.
Yeah, the main thing, CPUs are great, so we're going to continue using them for subsidiary services or for connecting to other things. So I think that's going to continue, but the main part of the calculations are going to be done by this technology. I think this is much closer to physics.
Yeah.
And if you're thinking from a historical point of view, when electricity was discovered in the 19th century by Maxwell, very quickly, lots of analog devices sprang out. TVs, X-rays, radios.
Oh, yeah, that's right. Okay.
But it turned out to be a mess because one application, one apparatus, and everything was simplified when digital appeared and everything was centralized. And then now we have lots of softwares, but now we have found a piece of software in artificial intelligence that can solve almost everything. So if you have one thing that can solve almost everything, why not design a simple piece of hardware, analog, to run it?
Fascinating.
So all right, we're there.
Yeah, that's very cool. It's fascinating that you've been working on this for 30 years and now you're finally able to pull it off, which is really cool.
Yeah. All my bets paid. Yeah.
Your bet's paid off. Well, Pablo, thank you for this. This has been a really interesting pitch. It's so compact and so complete that I'm almost kind of at a loss for words on how to describe it, but it's fascinating.
I'm glad you like it. Yeah.
All right. All right. This we'll send people to your website, Caspix, Caspix.ai and Caspix.io, X at the end there. And I guess people can check it out themselves. So thank you for joining us.
Thanks to you. Nice meeting you.
All right. This has been the Innovators. We will see you next episode.